On number 28, it says, given the two sets of data, which statement is true? It says, as compared to the mean absolute deviation, the interquartile range would better represent data set K. If they're suggesting that interquartile range is better than mean absolute deviation for a measure of variation, then they're suggesting that there may have been a what we would call like an outlier, a number that just does not fit the data. So let's look at data set K. We've got 2, 3, 4, 5, 6, 7, 8, and 11, and a 16. Those numbers are pretty close to each other. It's not like there's one that is like way off the charts that's different. So I would say that there really is not an outlier in this set, which would actually make the mean absolute deviation better to use. You want to stick to mean as your measure of central tendency and mean absolute deviation as your measure of variation whenever there is no outlier. Otherwise, interquartile range and median would be better to use. So I'm going to say probably not to A. Here we go. On B it says, as compared to the median, the mean would be more appropriate measure of central tendency to use with data set J. Well, let's look at the numbers in data set J. We've got a 1, a 3, 4, 4, 5, 5. We've got 8, 9, 10, 12, and then we have this random number 27. That's pretty far out there. That's more like an outlier here. So if we've got an outlier, it's better to use a median than a mean, but it's suggesting we should be doing the reverse. Probably, again, not our best answer. Then it says on C, the median of data set K is greater than the median of data set J. Well, let's go ahead and find the median for data set K. We need to put these numbers in numerical order. So we've got a 2 and a 3 and a 4. What I'm going to do is mark them out as we go through, just because it keeps us organized. We got 5, a 6, a 7, and an 8. 5, 6, 7, 8. And then 11 and 16. One good thing to do is check to make sure the amount of numbers you have here matches that. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. It matches. So let's find our median. Median would be the middle number. So we kind of cancel, 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 cancel. Here we go. And that would leave us with a median of 6. Now we're going to do the same thing with data set J. We're going to put these numbers in numerical order. So we've got the number 1 and then 3, so those cancel. Then I have 1, 2, 3, 4s. So let's cancel out the 4s. Looks like I have 2 5s. Cancel out the 5s. Looks like we have a 6 and an 8, a 9, and 2 10s. So 6, 8, 9, and 2 10s. And then we have a 12 and a 27. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Now let's go ahead and find our median for this. So the 1 goes with 27, 3 goes with 12, 4 goes with 10, 4 goes with 10, 4 goes with 9, 5 goes with 8. Now we have 2 numbers in the middle, and so to find the median, we would actually do the average. So you do your 5 plus 6 divided by 2, which is going to give us 5.5. So this said the median of data set K is greater than that of data set J. That is actually true, so that's probably our answer. And then it says the mean absolute deviation of data set K is equivalent to the mean absolute deviation of data set J. I can tell you just by eyeballing this would not be true because it has an outlier in data set J. That is going to throw that mean absolute deviation off and really bring it up in value when compared to this one over here. So not the best answer, which leaves us with C as our answer choice.